Hey everyone, and welcome to this explainer by Forge College. Today we're taking a pretty massive step forward in our Solana development journey. We're going to transition right from your previous lesson, planning the client interaction script, straight into mapping out your concrete script blueprints. So if you've been working on that high-level plan, well, this is exactly where we roll up our sleeves and actually turn those big conceptual ideas into actionable, rock-solid engineering. Let's get into it.
Okay, so how do we actually translate the conceptual diagram you just planned into a linear, fully testable integration workflow? Well, look at the big picture here. You've got your high-level plan, which is fantastic for understanding the overall goal, right? But it's abstract, and as we know, a computer literally cannot execute an abstraction. So we've got to shift gears. We need to move over to these concrete interfaces. This is where we define the absolute, exact, deterministic workflows required for deployment on Solana. By making this translation, we're making sure that every single interaction your script has with the blockchain is completely predictable, totally reliable, and 100% testable.
Now, the absolute crucial point here is that we have to treat these Rust-facing script interfaces, specifically stuff like your function signatures and data contracts, as strict communication contracts. Seriously, think of an interface like a legally binding agreement right there in your code. It's basically saying, hey, if you give me this very specific piece of data, I promise to return this specific outcome. No exceptions. By laying down these super clear communication contracts between your broad plan and the actual code implementation, you're totally eliminating guesswork. You'll know exactly what data needs to go to Solana and exactly what format it's got to be in.
To really wrap our heads around this, I love using this mental model. It brilliantly illustrates the dynamic we're dealing with. Just imagine your script is a conductor, okay? And the on-chain Solana programs and RPC endpoints, that's your orchestra. This gives us a really concrete way to reason about timing and responsibilities. Because think about it, the conductor doesn't actually play the instruments, do they? No, they coordinate the flow. They signal when to jump in, and they manage the entire tempo. It's the exact same thing with your script. Its job isn't to execute the heavy blockchain logic itself. Instead, it's there to coordinate all those requests to the RPC endpoints. It makes sure the on-chain programs get the right instructions at precisely the right time, keeping the whole performance, if you will, running completely smoothly.
So how does this actually translate into our code? Well, it breaks down into three core communication contracts: querying the necessary data, composing the transaction, and finally acting upon the blockchain. Let's start with step one, query. Just like a conductor needs to know if the violinists are ready to play, your script first has to fetch the current state directly from the blockchain. Next up, step two, compose. Based on the data we just queried, your script is going to build the exact transaction instructions needed. And then the grand finale, step three, act. Your script sends that beautifully composed transaction right back to the Solana network for execution. Honestly, breaking your workflow down into these three really distinct interfaces is a total game changer. It makes your code modular, super readable, and way easier to debug when things go sideways.
Now, a massive part of this whole workflow is how we handle the orchestra's feedback, because you're basically dealing with one of two outcomes. You're either managing the applause of a successful submission receipt, or you're gracefully handling the missed notes of a script error. Look, in Web3, you literally can never assume a transaction is just going to succeed. There's network latency, maybe some invalid data, or suddenly changing on-chain states. Any of these can trigger a failure mode. But by explicitly defining a submission receipt for your successful actions and a really well-structured script error for your failures right inside those interface contracts, your script becomes incredibly robust. It's not just going to abruptly crash when a node is missed. Instead, it'll know exactly how to recover.
Honestly, taking the time to design these interfaces and your per-function acceptance criteria right now, it's going to make your subsequent implementation and deployment completely deterministic and fully testable. You are effectively writing the grading rubric for your very own code. So, before you even think about writing a single line of complex Rust logic, you really need to finalize these key artifacts. We're talking about your compact interface sketches, your clear acceptance criteria, meaning what success actually looks like for each individual function, and of course, your step-by-step integration workflow checklist. This kind of prep work right here, that is the real secret to building high-quality, professional-grade Solana applications.
So as you go ahead and finalize that integration workflow checklist and start prepping for our next lesson, which is guided deployment and test execution, I want you to consider one really important question. Are your interfaces robust enough to handle a missed note from the orchestra? Really look closely at your error handling and those data contracts to make sure they are absolutely bulletproof. All right, it's been fantastic guiding you through this explainer today. Be sure to visit forge.college to learn more about Web3, dive even deeper into Solana programming, and just continue mastering these development frameworks. Keep on building, and I will see you in the next lesson.